Jai Hind to all. Myself Dr. Neelesh Kumar Gupta. I am working as a professor at Ajay Kumar Garg Engineering College in Department of Electronics and Communication Engineering. So students, now today I will deliver another lecture for a subject of DSP, that's Digital Signal Processing. Its AKTU code is KEC 503 and this lecture I have taken for unit number 4, that is mentioned in your AKTU curriculum, that's your discrete Fourier transform. So today I will tell you about the discrete Fourier transform. I will tell you what is the meaning of discrete Fourier transform, where we can use, what are the application of this discrete Fourier transform, their properties and so on. So I will discuss all the concepts relating discrete Fourier transform, that I will tell you. Okay. So I hope you studied earlier about the Fourier transform. What is the meaning of Fourier transform? Fourier transform means what? You are converting your signal from your time domain to frequency domain. Generally in communication system, we take the Fourier transform for getting the spectrum of that signal. If you want to draw, if you want to calculate what spectrum of any signal, then you need there the Fourier transform. And also we can say what the Fourier transform is like a bridge between the time domain and frequency domain. So you can convert your signal from time domain to frequency domain, and you can also obtain the spectrum of the signal. That's why we use the Fourier transform. Now you can take the Fourier transform for various type of signals like continuous periodic signals, continuous non-periodic signals, discrete non-periodic signal, discrete periodic signal. So continuous and discrete signals, and that should be either periodic or non-periodic. So these type of categories, for that you can take the Fourier transform. Earlier you studied in your 4th semester and 3rd semester the Fourier transform of continuous signal. In this lecture we will discuss about the Fourier transform for discrete time signal. Okay. So in discrete time signal we can see if, so here continuous and aperiodic. So this is the diagram or comparison between the Fourier transform for various type of signals. Like if you take the Fourier transform for continuous aperiodic, so you will get this type of spectrum. If you are taking the Fourier transform for our simple discrete time signal, so you will take this type of a spectrum. Okay, this is the your infinite length aperiodic discrete signal. If you take the simple Fourier transform of discrete time signal of infinite length, that is aperiodic, then it is called DTFT. DTFT means what? Discrete time Fourier transform. But if this length is of finite length and periodic, then if you take the Fourier transform, then it becomes DFT. So DFT means if you are taking the Fourier transform of finite length this and periodic discrete time signal, then it will DFT. So DTFT and DFT, these both are the Fourier transform of discrete time signal, but it is for finite and periodic length, and this is for the infinite and aperiodic, or you can say the simple discrete time signal. If we say in normal language, simple language, so we can say what? The Fourier transform of discrete time signal initially is called DTFT, that is called discrete time Fourier transform. But if you have to convert this signal for finite and periodic length, then it becomes DFT, and practically we prefer the DFT, not DTFT. That you have to keep in your mind. Always we prefer the DFT, discrete Fourier transform generally. Okay. So, but but you have to understand the difference between the DTFT and DFT both. So, if your signal is x of n is your signal, simple discrete time signal. So, if your x of n is your signal, okay. So, what will happen? So, its DTFT formula will be this one, okay. X of omega is equal to summation from n minus infinity to plus infinity x of n into e to the power minus ka j omega n, okay. So, this is the formula for calculating the DTFT for any discrete time signal. Similarly, you can calculate the inverse DTFT from this formula. So, these are the simple mathematical formulas, okay, by which you can calculate DTFT or its IDTFT. Okay. So, this is our simple DTFT. It means if you simply take the Fourier transform of our infinite late discrete time aperiodic signal, then it is called what? DTFT. Okay, discrete time Fourier transform. So, by these formulas you can calculate the DTFT and its IDTFT. Now, we concentrate on DFT because practically generally we prefer the DFT, discrete Fourier transform. If your sequence is of finite duration and periodic, then this Fourier transform of discrete time signal is called DFT, that is discrete Fourier transform. It finds application in digital signal processing, including the linear filtering, correlation analysis and spectrum analysis. Now, the formula for DFT sorry. So, if our x of n, our sequence is that is of finite length, so its N-point, n means finite, N-point DFT will be this one. This is the formula of DFT. What? X of k is equal to summation n0 to n minus 1 x of n into e to the power minus j 2 pi nk by n. Similarly, this is the formula of IDT. So, by these two formulas, you can calculate the discrete Fourier transform for finite duration discrete time sequences, and that should be periodic also. Your sequence and your Fourier transform DFT both will be finite, both will be of finite length and periodic. That you have to keep in your mind. In DFT, your x of n and your x of k both will be of finite length and periodic. That you have to keep in mind. It means small x of n is having the Fourier transform or DFT, N-point DFT of x of k, and its IDFT is small x of n. That you have to keep in your mind. Then you can easily solve the calculation of DFT and IDFT. Now, we come on the question. Now, this is a simple question. What? Find 4-point DFT for x of n is equal to cos of n pi by 4. So, we have to calculate here for this x of n, its DFT up to the 4 point. So, already in the question it is given to you up to the 4 point you have to calculate a DFT. So, n is equal to 4 here, okay, that is given in the question. Now, your x of n is given in terms of some cosine function. So, at first you have to calculate the value of x of n. So, x of n is equal to, if you put n is small n is equal to 0, so cos 0. If you put small n is equal to 1, so cos pi by 4. Similarly, n is equal to 2 and 3. You will go from n 0 to 3, 0, 1 to 3. So, now cos 0 you know, cos 0 is equal to 1. So, at small n is equal to 0, our xn is equal to 1. Cos pi by 4, it means cos 45 degree, 45 degree is 1 upon root 2, 1 upon root 2 means 0.707. Cos pi by 2, that is cos 90, cos 90 is equal to 0. Cos 3 pi by 4, it means cos 135, that is minus 1 upon root, that is minus ka 0.707. So, this is our x of n. Okay. Now, N-point DFT of sequence. Okay. So this is x of n that I have prepared from this cosine expression. Now its N-point DFT. So its N-point DFT x of k is equal to will be summation n0 to n minus 1 x of n into e to the power minus ka j 2 pi nk by n, where k tends from 0 to capital N minus 1. Because our DFT we are calculating for n point, the length is capital N. Here capital N is equal to 4, that is given in the question. So now x of k is equal to n0 to 3 x of n e to the power minus j 2 pi nk by 4. We are putting the value here. Capital N is equal to 4. Okay. If you solve this, then you will get x of k is equal to what? Summation n0 to 3 small x of n into e to the power minus j pi nk by 2. Now we have to put the various value of k and find out the its DFT in terms of capital X of k. So now if you put k is equal to 0, so x of 0 is equal to n0 to 3 x of n, because if you put in this equation, okay, let's this equation number 1. So in this equation if you put k is equal to 0, so e to the power 0 is equal to 1. So simply at k is equal to x of 0 is equal to summation n0 to 3 x of n, that is equal to 1. Why? Because if you add this plus this plus this plus this, you will get the 1. So capital X of 0 you will get here 1. Now put in equation number 1. Okay. Lastly, that I told in last PPT, if you put k is equal to 1, so capital X of 1 is equal to small summation small n0 to 3 small x of n e to the power minus j pi k is equal to 1 n by 2. Now you put the value from 0 to 3. If you solve this, you will get this one. So you have your calculations should be strong. Here e to the power minus j theta. So you have to remember the formula of e to the power minus j theta. That is what? Cos theta minus j sin theta. So if you know these formulas, so you can put here and easily solve. Similarly, x of 2 you can calculate, x of 3, and you will get your answer here. So x of k at 0 it is 1, at 1 its value this one, at 2 this, at 3 this, because you have to find out the DFT up to the 4 point. So now this is your answer. So I hope it is clear to everybody. Only you have to use the formula. You put the values and simply calculate the answer. Okay. So next we can go. Now another question. In this question we have to find out inverse DFT. If capital X of k is given to you. In earlier question what? A small x of n is given to you and you have to calculate its xk. It means DFT. Now this is the reverse. Now you have to find out inverse DFT, IDFT, if x of k is equal to 1, 2, 3, 4. It is given. Now if arrow is not given to you, so you have to mention arrow at the start. Now inverse DFT is defined as x of n is equal to 1 upon n. This is the formula that I told in last PPTs. Our inverse DFT formula is what? X of n is equal to 1 upon capital N summation k0 to capital N minus 1 x of k into e to the power plus j 2 pi nk by n, where n goes from 0 to n minus 1. Now if you put small n is equal to 0, because you have to put here x of k is given to you. Now you have to determine what? Small x of n. Okay. So for that you have to put here reverse process is there. Small n is equal to 0 in this equation. Let's this equation number 1. So if you put small n is equal to 0, so 0 1 by 4 k0 to 3 x of k e to the power j pi small n is equal to 0 into k by 2 e to the power 0 is equal to 1. So simply 1 upon 4 x of k will be added here. Okay, at 0 its value is 1, then 2, 3 and 4. So you will get 5 by 2. So x of k at 0 is value 5 by 2. So next if you put small n is equal to 1, So it will be small x of 1 is equal to 1 upon 4 summation k 0 to 3 x of k into e to the power j pi. Here k is equal to 1, sorry, small n is equal to 1 k by 2. Now again 1 by 4 1. So you have to calculate this expression according to this value. So x of k at 0 is equal to 1 k 0 e की power 0. Then x of k is 2 into e की power j pi k is equal to 1 by 2 3 is. So only you have to put the values here and you have to you can calculate your calculations in the form here e to the power j theta. So e to the power j theta, what is the formula? Cos theta plus j sin theta. So similarly plus minus, okay. So if here plus is there, so plus, if here it is minus, so it will be minus. Simple formula that you have to keep in your mind. So similarly you can calculate what? At small n is equal to 2, at small n is equal to 3, and this is your final answer. So IDFT, what? You have to calculate IDFT small x of n because capital X of k is given to you. Generally x of N-Point DFT is capital X of k and its N-Point IDFT small x of n. So in this question x of k is given to you. You have to determine what? Small x of n. So this is the correct answer finally of small x of n. At 0 it was 5 by 2, at 1 this value, at 2 this value, sorry, and at 3 this value. So your calculation must be strong in DSP, that you have to keep in mind, and that will be possible by practice only, okay. Now again this question, what for the calculation of DFT, what in the question? Derive the DFT of the sample data sequence x of n that is given in the question. So if error not given, so you have to assume at error is at the starting. So for this x small x of n you have to determine DFT and you have to compute its corresponding amplitude and phase spectrum. You have to determine, ये आपको निकालना है, ठीक. So what you know, N-Point DFT of a finite duration sequences, okay. So formula is what? X of k is equal to summation n0 to n minus 1 x of n e to the power minus j 2 pi k n by n. So initially what? Put k is equal to 0. So x of 0 is summation n0 to, so here capital N कितना है? How much? 1 2 3 4 5 6. So you have to go 0 to 5 n minus 1. So x of n into e to the power minus j 2 pi 0 n by 6. So small n0 is equal to 5, x of n. So only this is equal to 1, only x of n you have to add from 0 to 5. So it will be 1 plus 1 plus 2 plus 2 plus 3 plus 3. It will be 12. Now similarly k is put k is equal to 1. So x of 1 is equal to small n0 to 5 xn into this. Again you have to solve xn into e to the power minus j pi n by 3. Again as per the given values you have to put your values and using the formula you have to calculate the value of capital X of 1 and you will get this value will be this one. The same procedure, same calculation you have to do in DFT and IDFT calculations. Similarly k is equal to 2. If you solve and put the values, you will get k is equal to this value. Similarly, k is equal to 3, you will get this value 0. Now 4, k is equal to 4, k is equal to 5, and in this way you will have what? This your final x of k. At 0 its value will be 12, at 1 the next value, at 2 this value, okay. At 3, at 4, 5. So from k 0 to 5 you are calculating the value of DFT for given particular sequence of time domain. Okay. राहुल कितने मिनट हो गए? ठीक. So x of k is this, that is your answer. Now what in the question is asked, the correspondingly amplitude and phase spectrum you have to give. So corresponding amplitude spectrum, what you have to calculate capital X of k, that is amplitude means under root 12 into 12. Similarly here the root mean square of the coefficient of real whole square plus coefficient of imaginary whole square. Similarly you can calculate, and if you solve this you will get this one. So this will be your what, corresponding amplitude spectrum. Similarly you can also determine corresponding phase spectrum, that is capital angle of x of k tan inverse imaginary upon real, tan inverse imaginary upon real. Similarly you can calculate the angle of this and you will get this angle's value at different k from 0 to. So in this way you can also determine the amplitude and phase value of the DFT signal, and after the getting these values you can also draw the spectrum. Spectrum means the graph, the variation between the amplitude of that signal versus frequency. Similarly phase spectrum means what? Phase spectrum means the graph, the characteristic, the variation between the angle of this signal versus frequency. That's it. Okay. So you can calculate easily here. Now again find N-Point DFT for x of n is equal to a to the power n. This is the meaning of this, a to the power n for this. So similar simple formula you can use and you can determine the N-Point DFT. Okay. So this is N-Point DFT. In this you here a GP series will be there up to the capital N point. That's why you are applying here the formula of summation of GP series up to the finite number of terms. You will get this type of answer in this. You can see here. Okay. So in this type of simple question also can be asked in examination, and you should know also. Now properties, this is the very important. Now any Fourier transform or any transform, you know, all are having the properties. Why we use the properties? What is the need of property? Why we discussing? Because properties, using the properties, that transform, that calculation, that phenomena will be easy for us. Otherwise we know the formula of DFT and IDFT. So any type of question, any type of signal, if it is given to us complex or easy, you can calculate its DFT and IDFT easily. But using the property directly, you can use that property, and that will be easy for us. That's why we are discussing the property. That's all. So property will make easy our solution, our transform or anything. That's why every time we discuss the properties. So similarly here DFT properties. So like periodicity property, this is very important. What I told in my initial PPT of this lecture, what? Ki periodicity means what? Ki in DFT your x of n is also periodic and your x of k is also periodic. Both will be periodic, though both follow the periodic property. So here you will see further what, always in any type of shifting you can use the circular word. Why? Because circular or circle, that is only the space where your periodicity will be there. In circle you find the periodicity easily. That's why always you use circular time reversal, circular frequency shifting, circular time shifting, circular convolution, circular correlation. Everywhere where you shift your signal, what you find? You find circular word. Why? Because due to this periodic property. Because in DFT our time domain sequence is also periodic of and finite length. Similarly your DFT that you are calculating x of k, that is also is of finite length and period. So first property that I have you to keep in your mind, what? That your small x of n, your small capital X of k, both follows the periodic property. Next is linearity. Linearity means there is a simple property. If you are having two sequences, a small x1 n and a small x2 n, and its DFT is capital X1 k and X2 k, so it's as per the linearity property A x1 n plus B x2 n DFT will be A x1 k plus B x2 k. That you have to keep in your mind. Okay. Similarly, these property that I have written in this PPT, periodicity, linearity, then shifting property. In shifting, you will study about the circular time shift, circular frequency shift, similarly circular time reversal, then complex conjugate property, convolution, correlation, then multiplication of two DFT sequences, Parseval theorem, and so on. So, these all the properties we have to keep in our mind and we have to apply in the our problem. Okay. Now, its proof. Okay. So, these properties that you will study in this DFT, okay, and its proof also you should know, that also will come in examination. Okay. That also you have to keep in mind. So, its proof also you should know. This is mandatory to all of you. Now, circular convolution, correlation, Parseval theorem, and so on. So, earlier what we studied linear convolution now, but here we use the convolution as circular. So, that is very important that I am interested to tell to all of you what circular convolution. So, here the convolution is different, that is not linear convolution. Linear convolution is different, but in DFT we use the circular convolution. Convolution means what? Convolution means you generally you have to multiply two signals. So, always you use the convolution property in every transform, like Laplace transform, Fourier transform, zeta, everywhere. But in DFT this convolution is called circular. Why? Why circular convolution? Because in DFT your small x of n, your capital X of k both follows the periodic property. That is why. Now, you can calculate the circular convolution in three ways: graphical, linear convolution, and DFT IDFT. So, these are the three methods by which you can calculate the circular convolution. So, graphical convolution is new for you, and the numerical based on this graphical convolution will be asked frequently in examination. Simple, that is very simple. Now, linear convolution, then DFT IDFT. So, you can also calculate circular convolution using DFT IDFT. This method is also called Stockman's method. Stockman's method means what? You are calculating the circular convolution using DFT IDFT. Okay. राहुल कितना हो गया? राहुल कितना हो गया? 30. 5 मिनट खींच लूं, है ना? Next, circular convolution of two finite length sequences. So, this is the formula that I told in last PPT, the graphical. So, circular convolution you can calculate by this formula if two finite length and periodic sequences are given to you. Then you can calculate by this formula circular convolution. This formula came from the proof of property of circular convolution, that I hope you know, okay, or you studied in your classes, physical classes. Now, these are the some examples for what you can calculate the circular convolution using graphical method. Okay, so using graphical, it means you have to use this formula. Now, this another type of formula question for which you have to determine the circular convolution. So, compute the x1 n convolution x2 n, okay, this convolution for n is equal to 5 for given sequence. Okay, whenever you calculate the circular convolution using graphical, one thing also you have to keep in your mind, what? You have to keep your both sequences length is of equal. If x1 and x2n are given to you, so length of both sequences should be equal. Then you can convolute circularly, otherwise you cannot. So here in the question x1n is given to you, x2n is given to you. In x1n 1, 2, 3, 4, only 4 points are given you. In x2n only 3 points. So these are different, but we have to make equal. We have to make its equal length. Okay. So x1n, if you compare this from this, so x1n is equal to, so this coefficient 1, this one, this is minus 1, this is minus 1. Okay. So this is complete. Now x2n, if you see del of n, it means at 0 its value is 1, at 1 the terms is not there, so coefficient is 0, at 2 it is minus 1, at 3 it is not, so 0, at 4. So its length is what? 5. Its length is 4. So you have to at first what? These I have taken from the given sequences in the question. Okay. But we have to what क्या करना हमें? We have to try, we have to keep the length of both sequences will be equal. Okay. So its length is 4, its length is 5. So we have to make the length of x1n equate to 5. So what? It's 4. So you have to add 1 0 in the sequence of x1 at the last. This is called padding, 0 padding or 1 padding. Okay. Padding means you have to add some other 0 in sequences. For what? To bring length to 5 or bring the length equal to the another sequences. So now your x1n is this, x2n is. Now you have to convolute, and simple circular convolution of these two signal will be this one. Okay. So this is only I am interested to tell about the process and concept. Another depends upon your calculation ability and capability. Okay. This in this type you can do it. Now linear convolution, you know, x of k into h of k. So x of n convolution h of n. So using linear convolution also you can determine the your DFT and ITFT. So simple x of k into h of k. This is DFT of x of n. This is DFT of h of n. You can calculate easily. So using the linear convolution, using DFT also you can calculate the convolution. In this you have to ensure your overall length will be n1 plus n2 minus 1. n1 plus n2 means what? For this question, if you see. So here this length is what? n1 is what? Length is what? 3, 1 to 3. Its length n2 is equal to 2. So you have to ensure the overall length will be at least equal to the n1 plus n2 minus 1. So 3 plus 2 minus 1. So it will be 4. This. So as per this value, you have to add your zeros, padding zeros, and so on. So its length is 3. You have to make its 4. So you have to pad 1 0 here. Okay. This one. So this is your h of n. Its length is only 2, but you have to make 4. So you have to add 2 zeros. So this you have to keep in your mind whenever you use circular convolution, determine the circular using the linear convolution. Okay. So this is called padding zeros, zeros padding. Similarly, you can solve this one by using DFT, IDFT method and so on. So in this way, I try to understand you about the DFT concepts and its importance. Okay. So I hope it will be clear to everybody. If you have any question, any doubt, you can directly contact me. Thank you very much. Goodbye. Jai Hind.